Question B says, suppose a group of 25 bus riders come into contact with the virus and are infected. What is the probability that the average incubation time for those 25 people is less than 10 days? Now this time, we are not talking about individuals. We are now talking about an average in a group of 25. To symbolize this, I'll draw a large circle representing the population. Now ordinarily, previously we've been asked about individuals, which you can symbolize with these green dots. This time is different because we are being asked about a sample within the population. This is a group of 25 people. Now, because of this, because we are not talking about individuals anymore, we will have to make certain adjustments to the standard deviation. The standard deviation says 4.3 days, but that's for individuals. If we're looking at a group of people, the standard deviation will change. Instead of using a standard deviation of 4.3, we will now say that our standard error is equal to the original standard deviation divided by the square root of n, where n is the size of the group we're looking at. We are still being asked for a probability for our answer. So we are still going to use norm dist for our formula. We'll use dist anytime we need probability. We will make a slight adjustment to the formula and say x, comma mean, comma standard deviation, but this time we'll divide by the square root of the size of the group we're looking at, square root of n. We'll make this adjustment anytime we're looking at groups rather than individuals. But as usual, we'll say true at the end. Therefore, we have a slightly different list from last time to gather before we can do our math. We'll need x, mean, standard deviation, and n, rather than just x, mean, and standard deviation. Based on this, we can get p less. If we need to, we'll get p greater also. Let's first draw a picture of the situation. Here's our bell curve with a mean of 12.7. We want the probability of being less than 10 days. So 10 will be somewhere to the left of 12.7. And since it says less, less means left. So we are going to look at the small region to the left of 10. So for our x, we'll say 10 with a mean of 12.7, a standard deviation of 4.3, and an n of 25. To find the probability of being less, we'll use norm.dist. We click the x, comma, mean, comma, standard deviation divided by square root of n. We'll put the n in a set of red brackets and then say true. Once this is all in place, we press enter. And so the probability of being less than 10 for this group of 25 is extremely low. It's 0.00085. And this will be our answer for problem B. Problem C says, if there are 152 cases of Ebola in a particular country, what is the probability that the average incubation period for cases in that country is between 13 and 15 days? Once again, we'll draw a bell curve. The mean is marked as 12.7, and then 13 and 15 is the region we are looking between. 13 will be slightly higher than 12.7, 15 will be further along, and we're looking at this region between those markers. Notice that this time we are given a number of people rather than an individual, because we are being asked about an average incubation period. Now, since we are looking at a group of 152, we'll have to make another adjustment to our standard deviation. Once again, we're looking for probability, and anytime you need probability, norm dist is your first stop. So we'll say equals norm.dist. We'll say x comma mean comma standard deviation divide by square root of n comma true. So once again, we are making this adjustment to the standard deviation because we are looking at the average of a group rather than an individual. The key word here was average incubation period. Now let's gather up our pieces of the puzzle. The x values we need to check are 13 and 15. The mean is 12.7 for both. The standard deviation is 4.3 for both. And then the sample size that we're looking at is 152 because the size of the group is 152 for both. And then we can find p less for both. Equals norm.dist of x, comma, mean, comma, standard deviation divide by square root of n, comma, true. When we press enter, we have a p less of 0.80515. We can use the black cross and find the probability for the other x value as well. The x value of 15 gives us a very high probability, and Excel has rounded it to 1, even though it's not exactly 1. Because we have two x values, we can find the probability of being between them. Once again, we take the higher answer minus the lower answer. We'll say equals the 1 minus the 0.80515, and the probability of being between those two markers is 0.19485. That will be our answer for problem C.